Welcome you all. In this session, we'll discuss some numerical based on second law of thermodynamics. This is the problem. I am dictating this problem. The two reversible heat engines A and B are arranged in series. The heat engine A rejects heat directly to engine B. Engine A receives 300 kJ of heat at a temperature of 427 degrees centigrade from a high temperature source, while engine B rejects heat to a sink at 7 degrees centigrade. If the work output of A is 2 times that of B, find intermediate temperature of A and B, efficiency of each engine, heat rejected by engine B, that is heat received by engine B, and heat rejected to the sink. This is the problem. So first of all, let me explain the problem. This is a problem this is engine A and engine B. Both are reversible heat engine, remember. Both are reversible heat engine, are arranged in series. Both engine A and B are in series. Okay. So both engine A and engine B are in series. That means heat engine A rejects heat directly to engine B. Whatever heat engine A rejects the heat, the same amount of heat is received by engine A. That means heat rejected by engine A is same as that of heat received by engine B. Right? Engine A receives 300 kJ of heat. This engine A receives, let us suppose QA. This is 300 kJ of heat receives at this temperature. This is, let us suppose this T1, this is 427 degrees centigrade. Okay, from a high temperature source, while engine B rejects heat to sink at 7 degrees centigrade. While engine B rejects heat to this temperature having, this is 7 degrees centigrade. Right? So, right. If the work output of A, let us suppose this is WA amount of work is delivered by engine A, and WB is the work output by engine B. So in this question, WA is equal to 2 times of WB. This is given in question. Then we have to find the intermediate temperature. We have to find the intermediate temperature. Efficiency of each engine. Efficiency, we have to find the efficiency of A and efficiency of B. Heat rejected by engine A, that is heat rejected by engine A. This is what of this quantity of heat, and heat received by engine B, that is same quantity of heat. Whatever engine A is rejects, the same amount of heat is received by engine B. Right? This is the situation. The same this diagram is plotted here. This is engine A and engine B. Both are reversible heat engine. This engine A receives 300 kJ of heat at higher temperature. This is 700 Kelvin. This engine A, WA amount of work, and the Q2 amount of heat is rejected by engine A. Whatever the heat rejected by engine A, the same amount of heat is received by engine B, and the intermediate temperature is T2. Right? The engine B delivers WB amount of work and rejects Q3 amount of heat to the lower temperature, which is at 7 degrees centigrade. Right? This is the question. Then one more condition is given. Work output of A is equal to 2 times of work output of B. This is the condition which is given in question. Right? So in this condition, you have to find the required data. This efficiency of, we have to find the efficiency of engine A, efficiency of engine B, we have to find this intermediate temperature, this T2, we have to find this intermediate temperature, and we have to find this Q2. What is this quantity of Q2? These all data we have to find, right? Okay. Okay. For reversible heat engine, we know that this is very important. This, since engine A and engine B are reversible, and we know that for reversible heat engine, this Q1 by T1 is equal to Q2 by T2, right? This Q1 amount of heat is received from at temperature T1, and Q2 amount of heat is rejected by T2. Since engine A is reversible, therefore this Q1 by T1 is equal to Q2 by T2. Also, engine B is reversible. Both are reversible engine, right? Both are reversible engine. Once again, this engine B is reversible. Therefore, the same concept will be applied. This Q2 by T2 is equal to Q3 by T3, because this Q2 amount of heat is added at temperature T2 and Q3 amount of heat is rejected at temperature T3, right? So, by equating this both equation, what we get here, this Q1 by T1 is equal to Q3 by T3. This Q1 by T1 is equal to Q3 by T3. In this equation, this Q1 is given, this is given, T1 is given, and this T3 is given, from where you can calculate this Q3. This is equal to 120 kilojoule, right? So from this equation, this Q3, this is what is Q3? Q3 is the amount of heat rejected by engine B. This Q3 is calculated. This value comes with, this is 120 kilojoule, right? Now proceed ahead. This condition is given. This WA is equal to 2WB. This is given. What is WA? This WA is equal to, from this diagram it is clear, WA is equal to Q1 minus Q2. The WA is equal to Q1 minus Q2, and this WB is equal to Q2 minus Q3. Q2 minus this Q3. This WB is equal to Q2 minus Q3. Since WA is equal to 2WB, therefore this is equal to Q1 minus Q2 is equal to 2Q2 minus 2Q3, from where this Q2 is equal to Q1 plus Q23 by 3, and in this equation this Q1 Q3 is given, from where we can calculate the value of Q2. Therefore this Q2 is equal to 180 kilojoule. This value has been calculated. Now we know that we have already explained this fact. This Q1 by T1 is equal to Q2 by T2. Okay, therefore this T2 is equal to Q2 into T1 by Q2. This everything, all data are given. After putting the value, you get the value of this T2. This value is T2. What is T2? T2 is the intermediate temperature. This T2 is intermediate temperature, right? This T2 is calculated. Okay. And the efficiency of engine A, we know that this engine A is reversible heat engine, so efficiency is equal to 1 minus T2 by T1. This reversible engine A working between T1 and T2. Okay, so therefore this efficiency of this reversible, since this engine is reversible, therefore this efficiency is equal to 1 minus T2 by T1. All temperature has been given. After putting this value, you will get the efficiency of first engine A is 40%, right? And the efficiency of engine B is equal to 1 minus T3 by T2, because engine B is working between T2 and T3. Therefore T3 is lower temperature and T2 is higher temperature. So after putting this value, we will get efficiency of engine B is equal to 33.33%. So from this, all of these given data, with the help of this given data and concept, we can find out the different values whatever required in this question. Okay. So in this problem, there are a few concepts are required which are very important. Okay. this Q1 by T1 is equal to Q2 by T2 is equal to Q3 by T3. This is the key equation, right? For any reversible heat engine, we know that this Q is directly proportional to T, right? So with the help of this key equation, just we have calculated this required things. Okay, thank you.